In the following example, we are asked to express the number as the ratio of two integers. Basically, what they're asking us for is to determine what fraction would generate such decimals. So this one right here, this 0.77777 is just a repeated decimal. All right, so let's think clearly about how we might read this. Well, the 0.7 represents, first of all, 7 out of 10. The second 7 represents 7 out of 100. The third represents 7 out of 1,000, and so forth and so on, okay, as this repeats. So if we were to break it down to see what it actually looks like, well, it's 7 out of 10 plus 7 out of 10 squared plus 7 out of 10 to the third plus so forth and so on. All right, as we get to the nth power of 10. All right, so what we can do is we can use basically the sum of a series to figure out the formula, if you will. Well, not necessarily the formula. Well, we'll figure out the formula, but to find the actual fraction that generated this repeating decimal. And I think it's actually quite cool. So let's think about the first value, a. All right, what's the first initial value, a? Well, the first value, if you will, is just going to be a 7 out of 10. All right, so a is going to be 7 out of 10. All right, that's the initial value, a, right there. Well, if you think about it, each subsequent value gets multiplied by a factor of 1/10, right? So 1/10 is your common ratio. Since r is less than 1, we know that this will be convergent. All right, and because it converges, we can apply that formula that says if you take a and you divide it by 1 minus r, you can actually figure out what that fraction was. In other words, the sum of the series. All right, so let's see here. I'm going to apply what I know. 7 out of 10 divided by 1 minus 1 out of 10. And so let's see what this looks like here. This is 7 out of 10 divided by 9 out of 10, right? Which is 7 out of 10 times 10 out of 9. And what are we left with? 7 out of 9. All right. So this right here, and you can verify on your calculator, 7/9 generates this repeating 7 decimal. All right. Let's take a look at one last example here. 5.232323. All right. Well, the 5 is definitely in play here, right? So we're going to keep that, but that's not going to be our a value. We're instead looking to find what is the fraction that represents this right here, the repeating decimal portion. So let's see here. I'm looking at this and I'm going to say, well, that's 23 out of 100, 23 hundredths, right? And then that's followed by what? 23, you might have guessed it, 23 10,000ths, all right? Plus, and then again multiplied by another factor of 10, right? That's 23 1,000,000ths, all right? And I'll write it like that, all right? So what we're doing here is we're generating this, and we end up with, you know, this 23 over a power of 100 to the n. Just like that. So our initial value a then is 23 out of 100. And our r value is going to be this factor of 1 out of 100, because we seem to be multiplying every successive step by 100. All right. So we know that since r is less than 1, we can say that this, in fact, does converge. It converges. All right. And so we're going to say, okay, well, if we have 23 out of 100, and we divide that by 1 minus 1/100th, right? Okay, what do we get? We get 23 out of 100 divided by 99 out of 100. We remembered a KFC. 23 out of 100 times 100 out of 99. What do we get? 23 out of 99. But that's not the final answer, because to generate 5.232323, we end up needing to add 5 to that 23 out of 99. We need a common denominator, which in this case is going to be 99, so we multiply the top and the bottom, the numerator and the denominator of the 5 by 99 over 99. And then what do we get? Well, we get something like this, 518 out of 99. And that right there is how you would generate that decimal with this particular improper fraction. So again, really neat. When you have these repeating decimals, you can actually use these concepts here that we've learned. You can use these concepts in order to figure out what fraction actually generated them. So it's something really neat, probably something you've never thought of, but maybe you've wondered before, how in the world do they come up with that? This is how they do it. So as always, I hope this video was helpful, and remember, like and subscribe.